Hello everyone, this is Shatrupa and today we will be looking into DSA interview question. Now this video has four parts. First being basic data structure question, next being your medium level data structure question, and third definitely being your advanced level data structure question, and the last one will be scenario based, where there will be few scenarios given to you and you have to think what kind of data structure is basically being used. So we'll get started, but definitely before you look into the solution, just pause the video and think how would you answer that question if you were asked the same thing in the interview, right? uh, like think about it. Few answers, definitely I've written it from the first person point of view. That means the answers has I would do this or I have done this. So you can just replicate those, but definitely think about your own answer choices that you would say while you are answering that question. So the first thing is the basic data structure question. The first one is, what are the different types of data structure? So whenever we talk about different types of data structure, it so happens that we often think about arrays, stacks, queue, linked list, and everything. Those are data structures. They are not the types of data structure. So what are the types of data structure? There are only two types of data structure: linear and non-linear. Okay. So what is a linear data structure? So linear data structure, the elements are arranged sequentially. Okay. While in non-linear, the data does not form a sequence. Okay. Now, in linear, what is the biggest thing? That elements are stored in non-hierarchical manner, where each item has a predecessor and a successor. Okay, except for the first and the last element. Definitely, if you consider an array, string, linked list, right? But here, what happens? Here, element is connected to two or more items in non-linear arrangement. Think about a tree, think about a graph. In tree they are connected to two, like the left child and the right child, but if in a graph they have edges and vertices, there can be a lot of nodes that can be connected to each other, which is more than two, right? And this data structure is not sequential, so elements are not organized in sequential structure, not okay. So this is the basic difference between a linear data structure and a non-linear data structure, and these are the only two types of data structure. All right. Moving to the next question, that is, explain the difference between an array and a linked list. Now, very common types of linear data structure is an array and a linked list, and most companies prefer asking question based on arrays and linked lists. Like it is the most demanding topics. But how do you differentiate between them? Now, if you consider an array is nothing like the bookish definition that we all have read is that it is an homogeneous, continuous piece of memory, right? So, if you read it here, it acts like a box of memory, allowing quick access to the item by index. Since you can access it by index, now this is accessing the element which is already there. So, since you can access it, what will be the time complexity? Big O of 1. But, but remember, adding, or that means inserting or removing, that means deleting an item from the middle is challenging because you have to shift every other item. Okay, because if you don't shift an item, it will create an empty space. Now that empty space, right, it will definitely create an empty space. So if it is an empty space that is being created, then what will happen? It will become a discontinuous memory location, right? That value will no longer belong to that array and it will throw an error. So it is very important that whenever you're adding or removing, you have to shift the other items. Okay. Now, what happens in a linked list? You don't have to shift. Why? Because each of the nodes, they hold an item and the pointer to the next one. Okay. So this makes it easy to insert or delete item without affecting the whole list. Now there is no hollow space created in a linked list. You can simply remove that value, insert a new one, and just put the address as the next referencing location, whatever you want, right? So here it should be the time complexity is big O of n. Okay. So a linked list takes time complexity of big O of n. Now, what is a stack? Now, a stack is basically an ordered list. That is why, if you think about creating a stack, we always think that let's make it a list or an array, right? So, it is an ordered list which only has access to the top, right? So, that is why we say that if you want to remove something from the top, use stack, because stack is the only data structure that has access to just one end, that is the top, right? So whether you add or you remove an item, you're always going to do that from the top of the stack. Okay, so it is a recursive data structure. Now there is a very common question that is often asked, that which data structure is used for recursion? Stack is used for recursion. Okay, So why? Because recursion usually needs a call stack. Okay, so a recursion uses a call stack which keeps repeatedly calling the function. Okay, and that is maintained in the stack. So that is why recursion uses stack that maintains a pointer to just the top element. It does not have access to anything else. So stack is often referred to as LIFO, that is last in, first out. Okay, meaning that the element that was last added will be removed first. Okay, the other thing that stack can be used in several applications such as expression evaluation, backtracking, memory management, and function calls, and even returns. Okay, and there are chances when they can ask you to give a real world example where stack has been implemented and you use it every day. The undo and redo function in your word or anywhere, the redo and undo function, okay, that you use. Now, how do you implement a stack using an array? Now, very simple implementation. If you look into this, okay, that is exactly how you're going to implement it. Okay, so we'll come to this part later, like this part, my stack.pop. So first we'll read it here, that you can implement a stack using an array by taking advantage of last in first out principle. Think of array as a container with one end acting as the top of the stack. When you add an item, you use the push, and when you want to remove it, you use the pop. Okay, so in the following example, the push pop operation is implemented. So this is your stack, my stack, that is an array, right? This is an array. Now item is equal to 1, and what are you doing? You're basically going to append this item, this 1, into your stack. Okay, so what will happen? Your 1 will be added. Now if you want to remove this 1, if you want to remove this 1, you'll just do pop and it will pop this. Why? Because there's just one element, so the element itself is the top of the stack and also the end of the stack, so it's just going to pop that particular element. So this is exactly how you implement a stack using an array. Okay, so you have to give this code example. Moving to the next one. And I'm sorry for the question number. I do see all the question are number 3. So just ignore that. Okay. So we have around 30 questions, not 3 questions. Okay. So the next question says, explain the concept of a queue and its common implementation in Python. Now, if you talk about a queue, what does queue use? The first thing that queue uses is FIFO, first in, first out. So data structures that have the first element added to the list has to be removed first. Okay, so that is what first in first out is, basically slightly different than last in first out. Okay, so you can think that this is like a line at a store, the people enter from the back and leave from the front. Okay, use array or list and taking advantage of the methods like append and pop, but remember you usually use the word pop left. Okay, you use the word pop left for pop using queue. Using DQ. Now, DQ does not means delete queue, it means double-ended queue. Okay, so if you use double-ended queue from the collections library, then what will happen? It will append and it will pop functions quicker than the list. Okay, so you can basically use the inbuilt module, that is Q.Q, to do all of these operations. Okay, so this is basically what a queue is. Now, why did I mention so particularly the append pop Q.Q? Because in the question itself says in Python. Okay, so it would not make much difference if it is a different language, but yeah, still the libraries would slightly change or differ than that of Python libraries. Okay, moving to the next thing, but before that we'll look into this. So this is basically your queue. Okay, your item, and this is how you'll append it. You will pop it. Now you must be wondering, I just mentioned pop left, why did it pop just that? Okay, here there is just one element. Okay, here there is just one element. Now if you see here exactly when they're taking it from collection import DQ, you're using pop left, because if you don't do pop left, if you just use pop, then it is going to act like a stack. Okay, and it will remove the last one that was inserted when we need the first one to be removed when it's in case of a queue. Okay, so this is another example where you can see you can use queue and like q.q, that means from queue you will import queue, and we are just using the get function and put function to show you some things, right? Next is a very interesting question that is often asked about a binary search tree, that what is exactly a BST and how does it work? Okay. So before understanding a BST, I have written the definition for binary tree. Okay. So a binary tree is a data structure where each node has at most two children. One is the left child, the other one is the right child. That is a binary tree. Bi means two, so you have two kids. Now, binary search tree BST is a specific type of binary tree that has distinct ordering properties. Okay, the first thing, that the left subtree of any node contains node with keys that are less than the key of that node. That means at any given particular subtree of a binary search tree, the left nodes will always be less than the parent node or the key node. Similarly, the right node will always be greater than or will exceed the key node. Okay. Now, both left and right subtrees must also conform to the structure of the binary tree, both left and right. Okay, and these properties facilitate the efficient operations such as searching. Why? Because now if I want to look for a number, say 8, okay, and I have a binary search tree, now I am at a node, say 9, I know that 8 is less than 9, so I am only going to look in the left side of the tree without being concerned about the right side of the tree. I can just ignore one half of the tree. All right. So that is why searching, insertion, deletion, these are all very easy and can be completed in log n times if the tree is balanced. Okay. By balanced, it means it's a proper binary search tree. Okay. Now we'll see an example. So if you see this node 8, 3 is less than 8, so it's on the left side, and 10 is greater than 8, so it is on the right side. Okay. Now consider this subtree of 3, 1, and 6. So 1 is less than 3, so it's on the left side, and 6 is greater than 3, so it's on the right side. Now consider this subtree 6, 4, 7. 4 is less than 6, so it's on the left side. 7 is greater than 6, so it's on the right side. Consider this subtree. Okay, so 14 is greater than 10, so it's on the right side. Consider this 13 is less than 14, so it is on the right side, and on and all. If you see anything to the left of 8, that is 3, 1, 6, 4, and 7, they're all less than 8. Anything to the right of 8, that is 10, 14, and 13, they're all greater than 8. So this is technically a balanced binary search tree. Okay, moving to the next one. Explain the concept of hashing and its application. What is hashing basically? So hashing is a technique that takes data of any size and turns it into a fixed size value called the hash value using a hash function. Okay, so it takes data of any size and turns it into a fixed size called a hash value using a hash function. Okay, one common use of hashing is hash tables, where it helps to match keys with specific location in the array, making it easy to find and retrieve data quickly. Okay, hashing can have many applications. First of all is keeping passwords secure in cryptography. This is one of the major use of hashing. Okay, and definitely to keep data organized through deduplication. Okay, moving to the next one. What is a heap and what are its common uses? So heap is another data structure that resembles a tree, or it looks like a tree, but it has one special property. That is that in max heap, the value of parent node is always greater than equal to the value of its child node. Okay, this is for max heap. For min heap, the parent value is always less than or equal to the children's value. Okay, heaps are often used to create priority queues, which helps sort item based on their importance or priority or value, whatever you call them. They are also important for heap sorting, which is a method of organizing data efficiently. So if you look into this tree, now I can say this, it is a min heap. Why? Because this parent node is less than the child nodes. Okay. Similarly, this value, any subtree you pick up, 3 is 5, 6. 3 is a min heap. I mean, this is a min heap because 3 is less than 5 and 6. Okay. Similarly, consider 4. 4 is also 4, 7, 8 is also a min heap because 4 is less than 7 and 8. Okay. So that is how you know it. If had it been a max heap, it would have just been reversed, that the values of the parent node would be greater than the child node, or equal, greater than equal to. Okay. That is all with basic questions. We'll now look into intermediate level questions or slightly difficult questions. First question: how would you balance a binary search tree? Okay. How do you know that it is a balanced binary search tree? Binary search tree is okay, that the left side are smaller numbers, right side are greater numbers. How do you know it is a balanced BST? A balanced BST maintains a relatively equal height between its left and right subtrees. So balancing a BST is very important to maintain the efficiency or efficient search, insertion and deletion operation. Okay. The techniques like avial trees and red black trees are commonly used to achieve self balancing. Avial trees maintain height difference of at most 1 between the left and the right subtree of any node, while the red and black trees have stricter balance constraints. Okay, so you don't have to consider red and black tree right now, but you must know that what is a balanced binary search tree, that whenever a tree maintains a relatively equal height between its left and right subtrees, it is a balanced binary search tree. And why is it important to balance a search tree, binary search tree? Because it makes it more efficient in searching, inserting and deleting. Okay, so yeah, that's it. Now, this is an implementation of a min-heap in Python. In Python, we usually have min-heap. We don't have max-heap. So, in order to figure out a max-heap, what do? We use a negation of the min-heap. Okay. So, if you are using a negate, if you want to figure out a max-heap in binary tree, we always take negation of min-heap. Okay. But here it's a straight question. How do you implement a min heap? So first of all, your min heap will declare a, like, it will be within a class. Okay, so you're going to initialize it with self, and then you will have to get the size of the heap, then you'll get your parent index, then you'll get your left and right child. Once that is done, you're going to swap both the elements. Okay, now you're going to call the heapify function. For heap, we use a particular function called as heapify, right? So you're going to call that, and from here you're going to work over here, not here. So in that heapify, this will be heapify up, which will basically restore the min heap property after insertion, and this heapify down will restore the min heap property after extraction. Okay, so you're going to do this, and finally we have a definition, like a function definition of insert, where you're going to just insert the values into the min heap. You're basically building it, right? And finally you will have your extract function. What are you doing here? You will extract the minimum value from the heap. Okay, and you will return your min value, that is the top of the tree, the main parent node. Okay, so there is a detailed video about min heap and all of that in the data structure with Python course, so you can watch that and get a clarity about all the data structures that we have seen so far. Okay, moving to the next one. Explain the concept of a trie and its application. Now, trie is a prefix tree. Okay, tree is there, and prefix of tree is a trie. So, a trie is also known as a prefix tree, and it is a tree based data structure designed for efficient string retrieval and prefix matching. So what happens, that in a trie, each node will represent single character, okay? And the path from the root to the node correspond to the complete string. For example, over here, if you see, this is the root node, you have A, N, D. So the end word will be and. Here you have A, N, T. The end word will be and. Here you have D, D, A, D. Okay, so it will be dad. Here you have D and O. So you'll have do. Okay, so it's basically leaf node are basically complete words. Okay, so what is this feature use? Now this is a very interesting way of looking up for try. It's a very interesting topic and very easy to use. It's not complicated, much easier than using a tree. Okay, because you're basically building words and you would have fun doing it. You just need to figure out. So what happens, suppose I'm looking for the word and. Okay, so it's going to see A, it's going to come down this path, N, it's going to come down this path, it's going to choose a path, right? So it will come here, it will see, oh, it's D, A and D, but I want and, I want A and T. So it will go back to this node. Okay, from here it will see A and see, oh, there is another path, let me try this. Here it will find T, and you will finally find that word. Okay, now suppose if I had to look for A R K. Okay, I had to look for A R K. So it will see A, it will come down N. So it is going to go back from here itself and it will see that, oh, this is the root node. There is no R path at the side. It will return false. So try is actually one of the best ways of using it. Why? Because we use it in everyday life. That is the autocomplete, spell checkers. Okay, you have that. And even dictionary uses try. So it's a very interesting concept. Okay. Again, these concepts have already been explained in the data structure with Python course. So you can check out the course. Moving to the next one, how would you implement a hash table with collision resolution, right? Now, let me give you a heads up. The questions will keep getting harder from here on. Do not panic. It's okay if you don't know the answer. Look into the answer right now and then frame your own answers, right? Make it your own. Like you can see in this, I have written in my own experience. Like that, you can say as per my knowledge or what I know from that, okay? So, what is basically a hash table and how do you implement it using a collision resolution? So, in hash table, a collision occurs when two different keys produce the same index. Okay, so what happened? Two different keys, but having the same index. Not having, but they produce the same index. So to solve this, you need to use hash function to map the keys to specific indices of an array. Okay. Now, in my own experience, there are several methods for resolving collision, including chaining, where colliding elements are stored in linked list at corresponding index. And then there is one more, that is open addressing, which involves finding the next available slot in the array through probing. Okay, methods such as linear probing, quadratic probing, and double hashing. So these are the different types of probing methods. Okay, but I have mentioned two collision resolution techniques. One is your where did it go? One is your chaining. The other one is open addressing. Okay, so you can explain any one according to whatever you best know and best understand. Okay, moving to a graph question. Now here, understand the definitions are given in depth, so you get a complete clarity. But when you speak, you have to reduce the size of your sentence on all. You cannot go on and on for just like 2 3 minutes on one particular topic. Okay, so it says explain the concept of a graph and its different representation. So a graph is a data structure consisting of a collection of vertices, also known as nodes, right? So vertices are also known as nodes. We know that interconnected. How is it connected? It's connected by edges. Now, this structure is useful for illustrating relationships and connection between various entities. Now, if I tell you, give me a real world example of graph, what would you say? A basic thing is your connection requests, your friend requests, your mutual connections, right? Entire social media network that you have, that you know that, oh, I'm his friend, but he is not following me. How do you know that? Because at the back end, the graphs are actually connecting each profile to each other. If there is no edge, there is no line, there is no edge between you and the other person, that means one of you are not following. Okay? So, a real world example of graph is actually the social media network. Now, what are its different representation? There are two things. One is the adjacency matrix, the other one is the list. Okay, so the one that I prefer is definitely the list and not the matrix. Matrix is a little confusing because you need to fill out a lot of information in that. Again, this thing has been explained in details with the data structure Python course, so you can check that out. So what does a matrix do basically? So matrix is basically nothing but the matrix where you have all the values that you have to fill in, right? So it's basically a way to represent using a two-dimensional array where each element in the array shows whether there's an edge, like it's whether it is 1 or is it 0 or is it 1 and 2 or 3. How many links does it basically have? That is what it has to fill out. That's it. But it's slightly complicated. Okay, so if you look at the row for vertex I and for the column j, the value there tells you the direction. Okay, whether sorry, tells you if it is a direct connection or not. Okay, that means if it is a 0, there are no connection, while any positive number. Why? Because one node can have multiple connections with other nodes, right? In a graph, you just don't have two connections, you have more than two, right? So it shows you the weight of the edge. Weight means how many edges are there and how many nodes it's actually connected to, right? That's a matrix. But when it comes to list, so what is a list? So in this case, it uses list of lists. Okay. So each of the main list represents, so it's basically something like this. So you have like this, and you have been writing all of those within the bracket. Okay. So it basically represents a vertex. The inner list shows which other vertices is directly connected to. Okay, so directly you will just write 1 comma 3. That means one is linked with 3. Okay. So this is the way of organizing information, which is more often memory efficient than the adjacency matrix, because definitely it gets complicated by maintaining those zeros and whatever positive numbers that you have. Okay, so definitely if someone asks you what would you prefer, you would obviously choose lists over matrix. Okay, rest is up to you. Next, how to perform a DFS and a BFS on graphs. Now, DFS, the name itself suggests depth first search. So it is going to go down the tree or down the graph. Okay. While BFS itself says breadth first search. That means it will look through the levels, each and every level. Okay. So how is it working? It's like you want to figure out if there is someone living in the third floor or not. So what will you do? You will go from 1 all the way to 2 to 3. Okay. What you realize that probably that person is living in the second floor, right? So what will you do? If it was a breadth first search, you would have first scanned all through the first floor, all through the second floor, all through the third floor. Okay, so that is the only difference. Either you go 1 2 3 and then you again come back, again go 1 2 3, again 1 2 3, or you go 1, complete all the rooms, go to 2, complete all the rooms, go to 3, complete all the rooms. Okay, so that is the only difference. So DFS is an algorithm that explores graph or trees by diving deep into each of its branch. Okay, before backtracking, right? So first go to first floor room 1, second floor room 1, third floor room 1, come back to first floor room 2, second floor room 2, third floor room 3, again go back, first floor room 3, second floor room 3, third floor room 3, and so on and so forth. Okay, so it can be implemented using an explicit stack through recursion. This one can also be iterative. DFS can also be iterative, not just recursive. Okay, the time complexity is vertex plus the edge. Okay, where V is the number of vertices, E is the number of edges. Okay, meaning that it may need time to examine all the vertices and all the edges. It might so happen that it finds the element at the last node, right? So it has to actually go through everything, right? Now, next, what is a BFS? So BFS basically explores all the node given at a current depth before moving to the next level. So in the first floor, it's going to first look into all the rooms, so it never has to come back to first floor. It is for finding the shortest path in unweighted graphs and is typically implemented using a queue. So BFS uses a queue, DFS uses a stack. Okay, like DFS, BFS also has the same time complexity. So there is no difference in time complexity, but just how you implement it. Now, what is the trade off between different sorting algorithms? Okay, so sorting algorithms are essential for efficient data processing by enabling faster searching. You don't have to say this, but this is just written for your understanding. Okay. So it helps in improving data analysis, easier data visualization, and when it comes to sorting algorithm, I can see. Okay. So these first person use are for you, so you know how to present the answers. Okay. So the first one is definitely bubble sort. So you can say it is simple, but it is really slow. It has a time complexity of n square. Then it's merge sort, which basically does what? Divide and conquer, right? So it is much better because it's running in n log n, but it needs extra space and time because it relies on temporary arrays to put them back together, right? You say then you can say quick sort, so it works really well because it is running in n log n time on average. Okay, but in worst case scenario, it will be slow with n to the power 2. Why? Because of the pivot. What if you pick a wrong pivot element? Right? If you're not, most of the time, 99.99% of the time, you will choose the correct one, but in worst case, you just might not, right? So that is why in the worst case, it will have same time complexity as a bubble sort. Okay, so you can talk about these three sorting algorithms. If you want to talk about heap sort, go ahead and speak about your counting sort. If you want to, yes, you can, right? Insertion sort, selection sort, those are all up to you. Okay, and here are few implementations. So this is a bubble sort. Suppose this is your ARR is your array. So you're going to figure out the length. You'll run two loops, I and j. And this is the condition. At the end, you're just going to find that particular element and return it. Okay. Similarly, this is your quick sort. And so this is the helper function for implementing quick sort because we need to do the partitioning to find the pivot. Okay. And then you have your actual definition of your quick sort. So this is the condition to write down your quick sort. Okay. And finally, again, you're going to return that element. Similarly, this is your merge sort. So this is the helper function implementation of your merge sort. Why do you need the helper function? Because you are always dividing it into the right half and the left half, and then you're going to combine them. So in order to just figure out that, this is the condition, and this is how you're going to implement your merge sort. So this is basically merge sort. Okay. So moving to the next one, how would you approach the problem of finding the shortest path between two nodes in a graph? So now immediately don't start saying that, okay, this is the thing. So start with like a conversation that there are several algorithms that can be used to find the shortest path. But for unweighted graphs, that is breadth first search effectively explores the node layer by layer. Okay. So for unweighted, you're going to use BFS. For weighted, okay, and with non-negative zeros, you can use Dijkstra's algorithm. Okay, what can you use? You can use Dijkstra's algorithm that identifies the shortest path by examining the nearest vertex first. Okay, otherwise you have something called as the A star search algorithm, improves efficiency by using heuristic estimate. Okay, so you can use these three techniques to find your shortest path. First, BFS for unweighted, for weighted Dijkstra's, and you can use A search algorithm to improve efficiency, by which will use basically the heuristic estimate of remaining costs. Okay. With this, we have completed our intermediate questions. Now there are some advanced level questions that we'll look into. The first one being dynamic programming. Okay, so I know we all are scared of it, but dynamic programming is pretty easy. So explain the concept of dynamic programming and how it can be applied to solve problems involving data structure. So what does dynamic programming does is basically it is a method which solves complex problem by dividing them into small problems. Okay, that is the only thing that dynamic programming does. So it basically divides them, or you can see it, it divides them into smaller overlapping sub problems. Okay, so instead of starting from scratch every time, you keep a track of what happened to the previous part and then you just combine it. Okay, so keep track of those smaller solution, which means you do not have to do the same calculation repeatedly. So this method is very useful for finding the longest common subsequence between two strings or finding the minimum cost to reach a specific point on grid. So a lot of question can be solved using dynamic programming, and those can actually be one or two lines of code. Okay, so I have mentioned two examples here. You can dive deeper into further examples. Okay, the only thing it does is it just breaks a bigger problem into smaller pieces and then puts them back together. Now, explain the concept of B tree and its advantage over a binary search tree. Now, what are B trees? So, B trees are basically a balanced tree data structure designed for efficient disk access. Now, what does it do? Some features of them are like all the leaves are at same depth. Each node holds a variable number of keys within the specified range, and internal nodes act as an index structure. Now, you need to memorize all of these features, okay, in order to know the B tree. There is no alternative to that. So, just remember this. But what are the advantages over a binary search tree? That it has reduced disk input output, okay. So multiple keys can be stored per node and minimizing the number of disk reads needed to locate a specific key. And definitely once this is done, it is going to improve your performance. So for larger data set, its ability to handle more keys per nodes result in fewer levels in the tree. Okay. So since there are fewer levels, faster access and faster searches and faster result. Right. So these are the two advantages that a B tree has over binary search tree. Okay. Next, describe the concept of topological sorting and its application. Now, what is a topological sorting? So, it is basically a algorithm used for directed acyclic graph or called as DAG. Okay, how do you use them? It is used for ordering these DAG vertices. Okay, so how will you order them? Such that there is an edge from vertex U to vertex V, and then U appears before V in the order. Okay, so if there's a starting point A to B, then A occurs before B. Just ordering those vertices are called as the topological sorting. Now, why is this algorithm used? Where rather? So, one of the most common thing where it can be used is a task scheduling, where it needs to determine the sequence of the task that needs to be performed in a project, right? Like in the morning, you wake up straight out of the bed, you don't open your book and start reading. What do? You open your phones, right? So exactly the order. While you should actually go out, brush your teeth, and get ready and get started for the day. Right? So that order of what you want to do. Do you want to open your phone or do you want to go brush your teeth? Completely depends on you. But who's going to keep track in a system, in an algorithm? It is done by topological sorting. Okay. So a most common use of this algorithm is basically task scheduling. Now describe the difference between a min heap and a priority queue. So, what is a min heap? So, min means the topmost element will have the minimum value. Now, if I'm saying that this thing is on the top of my priority list, that means this thing is the most important or the one that has higher priority. So, basically, priority queue is nothing but a max heap. So, how is a min heap different from a max heap? That is exactly what you have to explain. So, a min heap is a specific implementation of priority queue. Yeah, it is an implementation of priority queue, but in opposite direction. That means the lowest priority comes on the top and is defined as a complete binary tree where the value of each node is less than equal to the value of its child node. We have seen that earlier in the video for efficient operation when finding and extracting the minimum element. On the other hand, a priority queue is an abstract data structure, okay, that permits insertion of element with the associated priority, with element being dequeued in order of their priority. Min heaps are common way to implement priority queues due to their ability to manage these operations efficiently. So why is it being said that we are using a min heap? Because there are no max heap in Python. If I just consider a general programming language, we always use a min heap and then negate it. Okay, so that is why. So min-heap is an implementation of priority queue, but on the other side. So why? Because min-heap will have the minimum value on the top. That means if I'm talking about minimum priority, then fine. But if I want the highest priority, then I'm going to use a negation of my min-heap. Okay. Moving to the next one. Explain the concept of disjoint set data structure and its application. Okay. So now disjoint data structure is also known as union find. Remember that people always ask what is a union find data structure. So it is nothing but a disjoint set data structure that maintains a collection of disjoint sets. That's it. This data structure only supports two things. One is to find, the other one is the union. That is why it is called as the union find data structure. So it determines which set is a particular element belongs to, and the union is basically merging of two set into a single set, right? There are many applications of disjoint data set, but to my knowledge, now this is how you will approach the answer. But to my knowledge, or as far as I know, the common ones are Kruskall's algorithm, okay, finding the minimum spanning tree, Prim's algorithm, also you can use. So and the network flow problem for determining connected components within a graph. Okay, Kruskal, Prim, everything falls under this disjoint set data structure. Okay, where you're basically figuring out the minimum spanning tree. So if you ask me, do I have to remember the complete Kruskall's algorithm? No, but you should at least know the approach. Okay, but if you ask me, should I remember the complete Prim's algorithm? Definitely yes. Yeah, because you should know it. It is an important base for determining minimum spanning tree. Okay, the MSTs of graph is basically Prim's algorithm, so you should know it. Explain the concept of segment tree and its application. Now, what is a segment tree? Segment tree data structure is designed to facilitate range queries and update on an array. It is particularly useful for the scenarios where we need to repeatedly perform operations such as finding the sum, minimum, maximum, greatest common divisor, even average, okay, over specific range of elements in an array. How do you construct it? So this is constructed using a binary tree. Okay, segment trees are basically binary trees where each node represents a segment of the array. The leaf node of the tree correspond to individual elements of the array. Okay, and internal nodes store information that aggregates the value of their child node according to the operations being performed. Okay, and this tree basically, like any binary tree, will have a time complexity of log n for everything, for even querying it and figuring out if there a number if there is an item existing, or updating it, that is inserting, deleting, changing the value, anything. Next, how do you implement a suffix tree? We just saw prefix tree was a try. How do you do a suffix tree? Now suffix tree is a data structure that stores suffixes of a string in a space efficient way, which makes it easy for searching strings quickly. Now building a suffix tree usually involves adding suffixes one at a time, but some unique techniques are called as suffix links that helps us speed the process. Okay, so if you ask me, this is all in all a complete answer. Okay. So what does suffix tree do? It basically helps you store the suffix of a string in a space efficient way. That means it is optimizing space, not time. And it makes it easier to search through quick strings, making it easy. Okay. And then what you can do, you basically build it involving or adding suffixes one at a time. Okay. And some techniques such as suffix links are used to help speed up the entire process. Okay, so this is the basic implementation of a suffix tree. No one will ask you to implement a suffix tree, but you should know how this thing is actually working. Okay, so this is a like a steady example of a suffix tree. So if you want, you can take a screenshot of this and just practice it or just understand the code. All right. Moving to the next one, like what are the quad trees and which are their most common application? Now, quad trees are basically hierarchical tree data structure that recursively subdivides 2D space into four equal quadrants. Okay, just like a graph with negative y and negative x axis. Okay, so this partitioning technique is highly effective for your applications such as image processing, collision detection, geographic information. Okay, so for these complex kind of things like image and collision and geographic information, we use quad trees. So quad tree is also a tree data structure, but here it is divided into a graph like this with negative y and negative x axis. All right, with this we are at the end of advanced data structure. We'll look into few scenario based data structure question. The first one, imagine you are designing a system for ride sharing service. Okay, which data structure will you use to match the driver with riders in real time? So, how do you answer this question? If you see, I have written due to the problem's real time nature, it is going to update you real time, right? Like you're booking a cab through Uber or Ola. How do you actually do it? You will basically want a real time update of where your driver is, right? So, this challenge will require efficient data structure. Now, this I'm not mentioning the data structure. I'm saying that, okay, since it is a real time nature, I addressed one major thing that he wanted to hear from me, the interviewer wanted to hear from me, that what kind of problem is this? Is it a static or is it a real time? Is it a dynamic problem? It is a dynamic thing, right? It's updating in real time. So in my experience, we just spoke about it, about the quad trees, right? Because I need geographical data of the driver and driver needs my geographical data. So what will I use? I will use quad tree for geographical data, priority queues to rank the potential matches based on the distance and rider urgency. So few data structures that I would need to use, and also hash table for efficient lookups of driver and rider location. So three things: quad tree, then you have your priority queue, and then you have your hash table. Okay, these three things. Moving to the next one, what data structure will you use to recommend product to users based on their past behavior? We can leverage a combination of data structure. Leverage, you can say, we can suggest or we can use a combination of data structure to effectively recommend product based on their user behavior. So a sparse user time matrix would store user product information, while hash tables would efficiently map users to items. Okay, so priority queues would rank the recommendation, and graph structures would model the user relationship. So if you have to suggest, if you want to build an app where you suggest people some product based on their past behavior, there are three things you would use: hash table for efficiently mapping what the user is actually looking for, priority queue just to make sure what are most searches that they have done, what kind of product is it, electronic, fashion, food, what is it, and graph to model the kind of relationship they share, like are they purchasing it, is it just add to cart, or are they just scrolling it. Okay, so you will use three data structures, right? Moving to the next one. You are designing a system for social networking platform. What data structure can you help detect and remove spam accounts? Now, a graph data structure can actually help in detecting and removing spam accounts on social networking platform. Okay. So a graph, how you can analyze the network topology by representing users as node and their connection as edges, identifying densely connected clusters, isolated nodes, and sudden spike in activity that can work as a red flag or suspicious account. Okay, so just one data structure graph, it can actually help you remove or detect spam accounts. Okay, What data structure would you use to deliver message to correct recipients on real-time chat application? Again, it says I would use. Okay, so it would be a combination since it's already real time. First, I would use is a hash table. Why? That would store IDs and their corresponding connection list. Okay, so I can easily look up that which user to send messages to. Next would be queues. Why queues? So that each user can maintain the order of messages. Okay, ensuring that it is delivered in sequence. Now I want to send it to my dad, then my mom, then my friend, then my fiance, then my husband, then my kids. So it is going to maintain that order. Okay, and lastly, trees. Why? It will efficiently store and retrieve users that are online and offline status, allowing real time update for user availability. Okay, so again, three: data structure, hash table, queues, and trees. Now, it's your turn that you think how you can improvise this. Can you improvise this? Maybe at times you can. Okay, so I'm not saying that these are the final answers, but try improvising all of these. Okay, next one. You are building a spell checker for a word processing application. What data structure would you use to store and search for valid words in dictionary efficiently? Now, for spell checker, what is important is lookup, right? So, if I have to look up, we just spoke about it, that try is the best one because at the end of the node, the leaf node is always a complete word. Okay. So this is a little more explanation about try that each node in try would represent a letter and the path through the try would form words. This allows fast prefix based searches enabling spell checker to suggest correction or misspelled words quickly. Okay. So what data structure for spell checker? Undoubtedly say it's a try. Okay. So this is Oh, I missed one question. Yeah. So, what data structure would you use to design a system for real time strategy game that efficiently handles area queries for structures and updates for new buildings? Now, if you consider this, you would definitely use a segment tree. Why? Because they are very good at handling range queries. That is what we read, right? And it will update efficiently. We can also represent the game maps as a 1D array where each element corresponds to the grid cell. Each cell can store information. So that's a little bit more explanation. So, two things. One is the segment uh, tree, the other one is a 1D array. Okay, so these are the two things that you will use. Now, here are going to be few TCS interview questions that have actually been asked in TCS, and I have not written the solution, so that is your work to think about the answers to these questions and try answering it yourself. All right. So the first thing is definitely tell me about yourself. Then is what is GitHub used for? I'm pretty sure we all know for version control and code update and just to keep make sure everyone is on the same page, right? What are neural networks? What is an SMTP? What's a NoSQL? What's an NPM? You can get some questions from machine learning as well. And then we do see another question saying that write an SQL query to get total student in each department. Pretty simple, but yeah, you should know how to query this. The next one is how would you print an array in Python? What is a blockchain technology? What are the OSI layers? So all the seven layers of networking should be mentioned, right? This is one of the managerial question. Why do you want to join in the IT sector? This is again a managerial question that tell a story on the water bottle lying in front of you. So pretty interesting question. You have to think about how you can present it. It does not have to be interesting, but it should be informative. Okay. Next two are your HR based question. How do you handle stress? What do you say about that? It's very important. And why TCS? Okay, so these are the few direct questions that have been asked in TCS interview. I want you guys to pause the video, just note these questions down, prepare your answers, try modifying it with every preparation, and you will surely get there, right? So, with this, we have come to the end of the video. I hope that you have found this video helpful. I will see you in the next one. Until then, keep learning and thank you.